welcome you all in this presentation related with the subject material processing, fundamentals and practical. And we are talking about the welding of metals. In this particular presentation, I will be talking about the 4 arc welding processes, and these processes are submerged arc welding, metal inert gas welding, tungsten inert gas welding and plasma arc welding. So, if we see, basically the granular flux is used for covering the arc zone and weld pool. So, this flux actually melts during the welding. So, like say there is an electrode which is uncoated electrode, this is the base metal, this is the weld line, and here an arc is struck, and around this granular fluxes is this arc and weld pool will be covered by the granular fluxes. Okay. So, a thin layer of the flux will be melted by the heat of the arc. Okay. So, basically the arc is covered by the molten flux layer. Okay. And then this molten flux layer will be flowing down gradually and mixing with the molten weld metal and floating at the surface of the weld pool. Okay. So, this is how the weld pool and the arc zone is isolated from the atmospheric gases, but most of these granular fluxes are oxide based. So, these oxides when decomposed they produce lot of oxygen, and therefore, weld metal produced by the submerged arc welding usually contains very high percentage of the oxygen. So, it is very rich in terms of the oxygen, and that will be leading to the like say various oxides in the weld pool. Okay. So, that is one that is the approach of the protection of the weld pool in the submerged arc welding. But as compared to the submerged arc welding, if we see other 2 or 3 welding processes in metal inert gas, tungsten inert gas and plasma, basically the inert gas is used for shielding purpose. So, helium or argon or mixture of these, argon plus helium mixture. Sometimes like say argon can be added with the other gases, like the argon can be mixed with the hydrogen or oxygen for achieving the specific set of the properties, okay, with this associated with the shielding gases. But when we purely use the inert gas, then this provides the very effective protection against the atmospheric gases. So, that is why they provide very good quality weld. Okay. So, both all 3 metal inert gas, tungsten inert gas and the plasma arc welding, all these 3 will be using the inert gases. But if we talk of the like MAGW, then there we can use like CO2 as a shielding gas or mixture of the CO2 plus argon. But with the plasma and tungsten inert gas, we will always be using the inert gas only. Okay. So, now we will be talking about these aspects a little in detail. So, say submerged arc welding uses consumable electrode which is uncoated, or if it is coated then copper coating is done to avoid the protection, to avoid the corrosion of the core wire, so of the electrode. So, the electrode is in form of the spool, okay, and this is fed continuously with the help of the electrode feeder, which will be having the rollers. So, electrode feeder will be feeding the electrode through the contact tube, which will be supplying the desired power supply. So, there is a power source which through the contact tubes will be feeding the will be supplying the power to the electrode and the base metal. Then arc is struck between the electrode and the base metal. Okay. So, this is say arc. Then around the arc there is a granular flux cover. This granular, a part of the granular flux cover which is immediately close to the arc zone, that will be melted. Okay. So, the thin molten flux cover is formed all around the weld pool and the arc, and that in turn helps to protect the weld pool from the atmospheric gases. So, this is arc, this is the thin molten flux cover, and this is the weld pool, this is the base metal. Part of the heat being supplied during the welding will be dissipated to the underlying base metal, and that will be producing the heat affected zones. Next to that there is a heat affected zone. Okay. So, so as far as the electrode is concerned, there is a continuously fed bare electrode in this process which is used. So, it can continuously supply the electrode. So, this feature is very good from the mass production point of view, because we need not to stop. Okay. The weld joints can be developed in meters continuously without any issue. So, this is good for a continuous feeding of the electrode. Okay. As far as the process parameters are concerned, say electrode, say if it is the steel based electrode. So, like say 20 to 30 volt is the normal arc voltage, but the current can change heavily, like say from 200 to even 2000 ampere. So, depending upon the electrode diameter. Okay. For a small diameter, the lesser current, for medium higher current, and for very large diameter it can be as high as 3000 2000 ampere. So, because if we supply very high current through a small diameter, then I square R T heating will be causing the excessive resistance heating, and that will soften the electrode and will create the difficulty in welding. So, if we have to do the welding of thick sections in one pass, then we need to supply huge amount of heat. To supply huge amount of heat, we need to generate large amount of the heat through the VI. Since our voltage is fixed, then we have to increase the current. So, depending upon the section thickness, heat requirement is affected, and the heat, if the heat requirement is increasing, then we have to increase the current. Okay. So, the current in submerged arc welding is primarily governed by the section thickness to be welded. Okay. So, as far as process parameter is concerned, voltage, current, and the welding speed. The welding speed we can choose certainly as per the requirement of the net heat input needed for development of the sound through thickness weld joint in one go. Say if it is up to say 25, but if it is further thicker, then we will be developing the weld joint in multiple passes. Okay. So, so the arc voltage, the welding current, and the speed, all these. So, apart from the arc voltage, the current and speed are selected as per the requirement of the net heat input. So, but the submerged arc welding is known as a high heat input process, high net heat input process, which can be like 3 to 5 kilojoule per mm. Okay. So, this is very high heat input that will help in realizing the through thickness penetration in one go in the thicker sections. Also, it will help in realizing the high melting rate. Okay. So, the high deposition rate is realized, and that will help in increasing the productivity. Okay. So, higher productivity through the higher deposition rate, which is being realized through the higher melting rate, and that is happening due to the higher net heat input or higher welding current which is used. Okay. So, this is another aspect. Now, as far as the polarity is concerned, you see usually the submerged arc welding is performed using the DC, so that the advantage of the self regulating arc can be done, and for realizing the self regulating arc, basically the DCP is used, a reverse polarity is used, where the electrode is connected to the positive terminal and the base metal is connected to the negative terminal. Okay. So, this is the power source. So, positive is connected to the electrode and the negative is connected to the workpiece. This is true for, you see, when we want to realize the self regulating arc, especially when the small diameter electrode is being used. But if the diameter of the electrode is large, then self regulating arc approach does not work, and in that case we can go with the DCSP also. Okay. So, depending upon the kind of the electrode which is being used, DC reverse polarity or straight polarity, any thing can be used. So, reverse polarity will be used for the small diameter and the straight polarity will be used for the large diameter. Okay. Then the heat input, some arc welding is known to be a high heat input welding process, say 30 ampere, 30 is the arc voltage and 2000 ampere is the current. Welding is being done at the 100 per minute welding speed, then we have to multiply it with the 60, divide it with the 1000 for converting into the kilojoules. So, if we do it like this, then so this will be resulting in the 36 kilojoule per mm. This is the kind of the net heat input. So, this is the too high heat input, but this will allow the welding of thicker sections, and when we use the high heat input, certainly it will increase the depth of penetration, but it will also increase the weld cross section. Okay. It will increase the heat affected zone width. So, there are many adverse effects associated with the high heat input, despite of the advantage of ability to weld thick sections in one pass, and because of the very wide heat affected zone, the significant degradation in properties of the steels takes place, and especially in case of the say hardenable steels, what we find reduced toughness, okay, reduced toughness and high hardness and reduced strength of the joint. So, the joint characteristics are badly compromised when the high heat input is used, and this is attributed to the not just for the martensitic transformation, but also formation of the coarse grained heat affected zone. Okay. So, the coarse grained heat affected zone coupled with the martensitic transformation compromises with the HAZ properties. So, in that case, if the property variation or property degradation of the parent metal is huge, then it may be required to do the post weld treatment in order to restore, primarily for restoring the structure and properties of the weld joint. Okay. And all these are coupled with the high heat input. Higher heat input means the larger weld cross section, wider heat affected zone, greater degradation in the HZ, degradation in the base metal properties, especially in the heat affected zone, and therefore, it will require the post weld heat treatment for restoring the structure and properties. The weld pool protection, as I have said, this is provided by the molten flux, when the flux will be reacting with the impurities to form slag. Okay. But still, since the mostly oxide fluxes are used, so the oxide fluxes produce the oxygen, higher oxygen content in the weld metal. Okay. So, in case of steel, if the acicular ferrite is promoted, then toughness is enhanced, but if that is not the case, then the all mechanical properties will be badly compromised. Why? Because of the reduced element transfer efficiency or reduced the concentration of the alloying elements, because some of these will get lost due to the interaction of the alloying elements with the oxygen. Okay. So, that is about the weld pool protection. Okay. Now, weld power source, mostly like say the DC welding is done using the reverse polarity for a small diameter and straight polarity for our the large diameter electrodes. About the weld metal and heat affected zone, because of the higher heat input, coarse grains are produced both in weld metal and the heat affected zone, and that compromises with the mechanical properties, and it produces also the reduced toughness, reduced strength, and therefore, post weld heat treatment is needed to restore the properties. Okay. So, now application and thickness and the quality aspects. As far as the thickness is concerned, this is primarily SAW, submerged arc welding, is preferred for welding thick plates. Okay. So, up to 25 mm thick plates can be welded without any edge preparation, square edges can be welded directly without any edge preparation requirement, and through thickness penetration can be realized in one pass. But if the thicker plates are to be welded, then we need to prepare the edges. So, this is one, but the high heat input allows the higher the deposition rate and higher productivity. Okay. So, the higher welding speeds can be realized due to the, and that is possible due to the higher heat input. Okay. Then, so certainly due to the higher heat input feature SAW is not used for the welding of thin sheets. As far as the quality is concerned, oxygen content in the weld metal is high. So, the weld metal will have the impurities in form of the oxide inclusions or the porosity. At the same time, heat input is high, H net is high. So, there is the degradation in the weld metal characteristics are not good due to the coarse grain structure, and also the heat affected zone properties like formation of the coarse grain HZ in the heat affected zone. So, these leads to the reduction in properties. So, impurity in form of oxygen and higher heat input, high net heat input, the SW leads to the reduced quality of the joints due to the reduced mechanical performance of the metal and the heat affected zone. To improve the properties, certainly we will have to use the post weld heat treatment in order to restore the properties. Okay. Now, as far as the metals are concerned, so very the metals which are very sensitive to the atmospheric gases like aluminum, stainless steel, magnesium, titanium, these are usually not welded by the W. Okay. Because the SAW does not provide very effective protection, especially against the oxygen, and therefore, if the metals sensitive to the atmospheric gases or the metals which are having the higher affinity to the oxygen, then those should not be welded by the submerged arc welding, but mostly the steels they do not create much of the problems. So, they can be welded by the SAW process. For most of the commercial grade welding, this W can be used for welding of the steels. Now, about the gas metal arc welding, this is also known as MIG welding, when we use the inert gas like argon or helium, or this is known as mag welding when we use the CO2, okay, or mixed with the other active gases. Okay. But both these categories can be clubbed using the gas metal arc welding. This is using this kind of the terminology. Okay. Now, electrode in the gas metal arc welding is similar to that of the submerged arc welding. Electrode is coiled in form of the spool, it is in form of a spool which can be fed continuously. So, this is also uncoated, or you can say bare electrode, uses the bare electrode, and this electrode can be matching with the parent metal, or it can be different one as per the case. If we need a specific set of properties in the metal, then it can be different, but this can be fed continuously. So, continuous feeding of the electrode is possible, that is done again with the help of the roller feeders. So, the electrode feeders having the rollers. So, rollers will be feeding the electrode through the nozzle, where we have contact tube, power is supplied through the contact tube to the electrode, and then there is a power source. One end is terminal, one end of the power source is connected to the one terminal of the power source is connected to the electrode, and another is connected to the base metal. Usually, that is about the connectivity, and when the electrode this we can electrode can initiate the arc using the two methods. We can use touch start method, or we can also use the field start method, but touch start is one of the most common method. In touch start, our electrode will be brought in contact with the surface of the base metal, which is, so the circuit is closed, then it is withdrawn, and then arc is established. Now, so the electrode through the nozzle, electrode will be coming, and through the nozzle also will be, through the welding torch, we will be supplying the shielding gas. Shielding gas will be coming out of the nozzle, and the electrode will also be coming out of the nozzle. So, the arc is established between the electrode and the base metal, and the shielding gas which is coming out of the nozzle will be forming a cover around the arc. and the weld pool. Okay, that's how it will be providing the protection. So the heat of the arc will be melting the base metal, okay, to produce the weld pool, and the part of the heat will be distributed to the underlying base metal to produce the heat affected zone all around it. Okay. So shielding is provided by the suitable inert or inactive gas, which may be CO2 or helium or argon. Okay. And so if the argon and helium is used, then they provide more effective protection against the atmospheric gases, and they help in producing the more better quality weld as compared to that of the CO2. Okay. So here if you can see, the positive terminal is connected to the electrode and the negative terminal is connected to the base metal, means we are using the DC-RP, reverse polarity. Okay. And when the negative terminal is connected to the, when the positive terminal is connected to the electrode and negative terminal, when negative terminal is connected to the electrode and positive terminal is connected to the base metal, then we have the DC-SP, straight polarity. Okay. In a straight polarity, negative terminal of the power source is connected to the electrode and the positive terminal is connected to the base metal for the straight polarity, but usually we prefer to go with the reverse polarity in case of the SAW and GMAW processes, especially when the small diameter electrode is to be used to take the advantage of the self regulating arc. Okay. So that the arc length is automatically adjusted when this kind of the arrangement is used with the constant volt power source. Okay. So this the electrode used in submerged arc, in electrode used in gas metal arc welding is smaller than that of the submerged arc welding, because this is a relatively low heat input process. This does not carry the current that 1000 or 2000 ampere, maybe 300, 500 ampere current is the commonly used. So this is primarily used for the small diameter electrode. Okay. So the diameter of the electrode is not as much as that of the SAW process. Okay. So here continuous bare electrode, continuous fed bare electrode is used, and this is usually small in diameter. Okay. The welding current, the voltage, arc voltage, welding current, arc voltage, welding current, and the welding speed. Okay. These are the three process parameters. These need to be adjusted considering the type of the electrode metal. We can use suitable weld 20 to 30 volt. Okay. The welding current as per the need 100, like say the 100 to 500 ampere current, and the welding is like say the 50 to 200 ampere, sorry, mm per minute kind of the speed can be used. Now, how to choose this combination, that will depend upon the diameter of the electrode, okay, the metal of electrode. Okay. And then net heat input is to be used, net heat input that is needed for welding of a given sheet thickness, whether it is the single pass welding where through thickness penetration is needed, or it is a multi pass welding where you need to supply we need to use the multiple passes for developing the weld joint. So accordingly, if it is the single pass welding, then we may have to use the higher heat input for especially in the moderate thickness plates. But if it is very thick one, then we need to go with the multi pass welding, and in that case the lower heat inputs are used. So the point here is the H net to be used will depend upon the section thickness to be welded. So what we do, assuming a particular arc efficiency, we use a suitable combination of the welding speed and the current, okay, for realizing the desired heat input. Okay. Now, the polarity usually for the smaller diameter to take the advantage of the self regulating arc, DC-RP is used, while DC-SP is used especially with the large diameter electrodes, but if it is the non-ferrous metals, then AC welding is used. In case of the GMAW process, like for aluminum welding, AC is used. Alright. Now, the heat input as I have said, that can be adjusted using the welding current and the welding speed as per the thickness of section to be welded. The protection of the weld pool here is provided by the shroud or the cover produced by the inactive gas in case of the mag welding, okay, or it can be inert gas welding in case of the MIG welding. In case of the MIG welding, it can be inert gas like argon or helium, otherwise it can be CO2 also. So, the protection is reasonably good, protection is good, and that is why the welding process provides the reasonably good quality weld joints. Okay. Now, we have the welding power source, we can use both DC or AC. AC is used for the non-ferrous metals, and this DC is used especially when you want very controlled heat input, either it is on the higher heat on the base metal or the lower heat on the base metal, okay, or we are looking for the self regulating arc. So, high or low heat or self regulating arc. So, depending upon the need, we choose the suitable type of the power source, AC or the DC. Okay. AC is preferred for the non-ferrous, DC is preferred, DC RP is preferred for regulating arc, and then the DC RP is also preferred for higher heat input on the base metal side, and DC SP is preferred. State polarity is, so DC RP is preferred for the low heat in the base metal side, and DC SP is preferred high heat in the base metal side. So, this is the kind of combination. So, when we want a specific control over the heat input, then we also use the suitable type of the polarity. Okay. Then the weld metal and the heat affected zone. Since the H net used during the GMAW is lower than that of the SAW, also it is lower than that of the SMAW, and therefore, so lower H net results in the smaller weld cross section, okay, and a smaller HZ. Okay. So, smaller HZ width and the smaller weld width cross section. So, both these are the undesirable thermal damage that will be taking place in the base metal. So, the kind of the weld cross section that is produced and the heat affected zone produced by the GMAW process, this is narrow, and HZ is also narrow. So, both are in favorable as compared to that of the SMAW and SAW processes, that this difference primarily comes from the net heat input. Okay. So, because the H net is less, so our cooling rate is high, and higher cooling rate helps in producing the refined grain structure and reasonably good the weld metal and HZ properties. Okay. So, because of this difference in the heat input and more effective protection of the weld pool by the GMAW process, we get the reasonably good quality of weld joint by the GMAW process. So, there are two main factors, low H net and the good protection of the weld pool. This helps in producing the reasonably good quality or very good quality weld joints for most of the commercial applications. So, for this can be used for both thin as well as thick section components. If it is thin, then we will be using the one pass single pass through thickness penetration. If it is thick, then we will be using the multi pass welding. Quality is really very good because of the low heat input and good protection, and this is preferred especially for the non-ferrous metals or the metals which are sensitive to the atmospheric gases, or they like they are having very high affinity to the atmospheric gases like oxygen and nitrogen. So, if that is the case, then the GMAW process is preferred, or we want really very good quality weld joints of the steel also. So, if either the quality requirement is high, or if the metal to be welded is very sensitive to the atmospheric gases, then in both the cases the GMAW welding process is used. So, now I will summarize this presentation. In this presentation, basically I have talked about the various technological aspects associated with the submerged arc welding and the gas metal arc welding, and how these two processes can be compared with respect to the quality of the weld joints that is produced. Thank you for your attention.